So next we are going to look at under voltage and over voltage. When we say under voltage, okay, what we mean is that the voltage is less than the normal voltage level that we expect in our system. So if it is less than, say, 90%, okay, of what we expect in our system for about, say, more than 1 minute, that is under voltage. And under voltage, remember, the electric motor will exert a definite level of power in our system. Are we getting it? So since P is equal to IV, P is constant, V has gone down. What will then happen to I? I will definitely go up to balance up the differences so that we'll have that constant power, okay, on the system. So if I goes up, what will then happen to the heat that is dissipated in the winding? Of course, remember the effect is exponential, okay, because the heat that is dissipated is given by I square arrow, okay. So that is why under voltage is not good for our system, because it will increase the heating level of the electric motor, reduce the insulation capability, destroy the electric motor insulation, cause winding burnout. Are we getting it? Especially if the under voltage is sustained for a very long time, or it is repeated over a period of time, okay. So the next that we are going to look at is over voltage. So when we say over voltage, that is, the voltage is more than what is expected in our system, okay, say about 110% and above. And if it stays for more than 1 minute, okay, that becomes an over voltage. So such over voltage is also not good for our system. Are we getting it? It's not good for our system because it has the tendency of increasing, apart from increasing the losses also, okay. You see that the motor will tend to want to run at a higher speed because of that increased voltage level, which may not be good for the end products in our system, okay. So over voltage, again, apart from that too, it also has the effect of stressing the insulation of the electric motor system. Remember, these insulations, they are designed to withstand a level of voltage, okay. That determines the breakdown capability of this insulation. So you're repeatedly stressing them with something that is beyond what is normal will eventually make them to give way, especially at the weakest point on the insulation. So over voltage too, we need to protect our system against over voltage. So we also have other power quality issues that can affect the reliability of our electric motor system, and that is sags and swell, okay. Sag, like under voltage, is when we have about that 90% power unit, okay, into our system, but this time at a lesser time. It has a very short duration, that is from 0.5, that is half circle of the voltage signal, to about 1 minute, okay. Then swell too, like over voltage, 110% and above of the standard power unit in our system. Are we getting it? But this time, it's for a lesser time. What that means is that if that overvoltage is experienced, okay, for between half a cycle to about 1 minute, that becomes a swell. Are we getting it? So sags and swell, like undervoltage and overvoltage, they are still not good for our system, okay? Because undervoltage, that repeated increase current flow over, that is sag now, repeated increase current flow, okay, stresses the conductor and the insulation. Then over voltage, that is swell now, also has the effect of increasing the stress. Remember, the pressure on the insulation of apart from the increased speed that it will eventually cause on the system. So there are some of the power quality issues or signal or abnormalities that we need to guide or protect our system against. Then we have flickers, that is, the voltage is fluctuating randomly or irregularly. Are we getting it? It's like when you flickers, you notice it in bulbs. Maybe if you have fluctuations, frequent fluctuations on the voltage signal, those incandescent light, you see it going up and down, as you can see on your screen on that incandescent light right now. Okay, it will be going up and down. That is called flickering. Are we getting it? So flickering too is not good for our system. Okay, it's not good for our system because, like the sags, overvoltage, and the rest, they can cause shutdown. Depends on the protection you have on the system. Can cause shutdown, and at times it will take you a lot of time to start up the system again. Then if production is in process already, you see that those materials that have been prepared for the next stage of your production process may be wasted. Are we getting it? And so these flickers too can also cause similar effect on the electric motor system. So we want to guide against this. So the next that we are going to look at is transients. Okay, transient, basically they are introduced by lightning. They usually appear as spikes in our voltage signal or waveform. You see that spike will overshoot the limit, okay, of they are usually very, very high. Remember, when lightning strikes, it creates electromagnetic field. Okay, that electromagnetic field that is created as the lightning is discharging into the earth induces voltage into our electrical system. These are the spikes. They are usually very, very high voltage. So if they are allowed into the system, okay, it has the effect of causing insulation breakdown or stressing the insulation repeatedly. It will eventually cause breakdown if your insulation is that strong enough. But in some cases, as it enters, that first entry can destroy the insulation of the components in your system. Okay, so we want to protect our system against such transients that may happen in the system. Okay, so we have discussed voltage swell before, and this one that we saw here, this is sag. Okay, this is the sag. It lasts for less than a minute. I will get it from half a second to about a minute. Then the swell, you see increased voltage that lasts for the same half a second to about a minute as we discussed before. Then we have voltage interruptions, or we have interruptions. That is when there is a break in the voltage waveform or signal, okay, for more than 1 minute. That is called interruption. Are we getting it? So such interruptions too, they are not good for the operations of the electric motor system. Are we getting it? So all of this we need to protect against. Then variable frequencies. Frequencies, the frequency of the electric motor of the power supply have a way of affecting the speed, or it affects the speed of the electric motor itself. Okay, so when the frequency is fluctuating, that will cause fluctuation in the speed of the electric motor, that will eventually cause fluctuation in the rate of, that is the rotational speed of the driven equipment. So this driven equipment, if it is a pump, it means that at times it will deliver more than what is expected, and at times it will deliver less than what is expected. If it is compressor, the same thing too. Okay, and such variation we know is not good for our process, especially for sensitive process. Okay,